With this packer, we are highlighting a trapdoor grid. We will get an overhead view of the grid in operation in just a few moments. This application is a very slow speed operation, and it would have been handled very well by the compact drop packer. However, the cans were so heavy that this application was better served by the DP4. Now, as we view this packer from directly overhead, we can see that the grid consists of two solid plates that come together at the center line of the packer. This allows the cans to slide into the grid area, and when all 6 cans are in, the 2 plates pull quickly apart and gravity takes over, allowing the cans to drop into the case below. Notice that this application calls for 2 layers of cans to be packed into each case. There are 2 good reasons for a trapdoor grid. Number 1, for heavy containers, such as the cans that you saw in the previous application, or also half-gallon or 1-gallon bottles. The trapdoor grid simply gives better support and strength for these type of heavy loads. The second good reason for a trapdoor grid is for quick changeover, or literally no time lost in the grid when going from one bottle to the next. This packer was built primarily for 1-gallon jugs of Elmer's glues. But here the trapdoor is also packing rectangular quart bottles in a 3 wide by 2 long pack pattern. With a trapdoor grid, there is literally no changeover time lost in the grid area when going from the 1-gallon to the quart and then back to the gallon. Another grid that works very well with heavy bottles is the Bombay grid, as illustrated on this packer. Here it is packing bottled water in 1-gallon soft plastic rectangular milk jugs. The Bombay grid is similar to the trapdoor grid in that it also has 2 plates that open up to allow the bottles to drop. However, with the Bombay grid, these plates do not pull apart, but they open downward.